Good morning, ladies and gentlemen. Today I would like to talk about story of light. It is needless to explain why we need light in our daily life. But it is actually very important to understand the light, the concept of light, or the composition of light from a scientific perspective, or from a scientist perspective. So that's the reason I have decided to give a kind of series of presentation which actually covers some ideas or some information about light. So the outline of my presentation for today's presentation, first I will briefly describe why light, and then I will talk about how light travels, and then I will talk about the composition of light, waves or particles, and then followed by this I will talk about speed of light. Can somebody knock out? And then I will talk about how many colors in sunlight, and do you really only 7 colors in our life. So today I will be only talking about only this 6 points, but there will be kind of at least a series of presentation. Then in the following presentation I will cover some rest of the topics. Okay, so you know that in general individual title or individual topic, one can give a whole presentation or 1 hour presentation of individual topic, but that is actually not my intention. My intention is to give you briefly some ideas about the overall ideas about the light. So let me begin with why light. So one of the famous Indian poet and writer, Rabindranath Tagore, for children once wrote 2 sentences. In Bengali this reads like alo hoy gelo boy. Now if you directly translate these 2 sentences, this reads like light is on, fear is gone, or something like light comes, fear goes. So that means the light is actually it's a kind of confidence in our life, right? So we quite often we talk about light is hope, light of knowledge, and light of education. We also talk about light means freedom, right? Light means progress, and light means power, and light means energy. And not only that, sometimes we can also describe light as a kind of mystery, right? And light means also the question. So in ancient times, man used to look at the skies and with curiosity, and why stars are located so far, and why they are emitting lights. These were the questions they were asking maybe thousands of years. And if you see this, for example wise, in 230 BC, this Aristarchus of Samos was a great Greek philosopher. Actually, the first time he looked at the skies, he was the first to describe that the sun is actually located in the center of the solar system. So, and he was the first to demonstrate that. And not only that, he also told that just looking at the skies, looking at the other stars, he was telling, maybe you see these stars maybe are similar to the sun. So that was the question, or that was the things he already informed us in 230 BC. That was long time ago. And then people started to look at the sky, people started to look at the light, and they try to understand how light travels, and what are the constituents of light, what are the compositions of light. So these are the questions they wanted to know, and they wanted to know light. And with that, people also have understand the characters of light, and various things about its movement and so many things. Through this, actually, the science has also has a huge amount of progressed. Yeah. So that means, so if you really want to be a science-minded person, or if you want to be a thoughtful person, so that means if you don't understand or know something about light, I think it is very frustrating, and it is not really a matter of pride. So that's the reason I think my title of the slides reads like why light. So the light is a really integral part of a light, and we should really understand light from a scientific point of view. Okay. So now I will talk about the direction of light, or the how light travels. You know, so when you are sitting in a room, yeah, and then somebody knocks your door, yeah, your door is closed and somebody knocks the door, and you cannot see him, right? But you can hear the sound of that person outside, those who are actually sitting outside, or somebody is talking your neighboring room. And if you don't really have a soundproof wall, then you definitely listen to him, yeah, but you cannot see him. So what does it mean? That means actually the light goes straight, yeah. It can't turn around if there is an obstacle, yeah. So that in front. So that means when light travels, he observes or encounters a obstacle, and there is a darkness behind this obstacle, and this is why shadows can be seen. So example wise, I have shown here kind of light and shadow. So there is a sun, little bit cloud, and 4 children are actually, or boys and girls are playing, and then you see they are some kind of obstacles, and you can see the shadows there. Yeah, so this is the way light actually moves and produces the shadow. So that means the light cannot really all the time bend, and so that means the light goes in general in straight. Now let me briefly give you a small example, and this experiment you can do in your house. Let's take a glass of water, and then in this glass of water you placed a pencil or pen. So now if you see from the outside, then you'll see that the part of the pencil that is submerged in water seems to be bent. Yeah. So why this has happened? So to explain this, actually Wilbrod Snellius in the period 1580 and 1626, a Dutch scientist, first gave the idea when light travels from one medium to another, how much it will bend. So he was the first person to demonstrate. Yeah. And later on, if you want to do a little bit more sophisticated experiments how light bends, so if you take a laser light, like in the bottom part of the right side I gave another picture. So there is a water, and this water, if you really placed laser lights, for example green laser light, you see the green laser light moving, and as soon as it enters into the another medium like water, it actually bends. Yeah, that is a little bit more advanced in the sophisticated ways of seeing the things. So what happens in earlier times, when start our civilization, people started to look at the water, and they saw they observed their reflections. Yeah. And slowly they understand, okay, for this reflection probably you can also discover the glass or the mirror, and in mirror you see very perfect or very nice reflection through your the light goes to you, the light goes to the mirror and the surface of the mirror, and it reflects to your eyes, and you see the kind of reflection of yourself. And this kind of the bendings of light, why does this light bend from one medium to another? And this was later on explained by the French scientist Pierre de Fermat, and he actually gave a definition, and the definition is the following. For example, the light travels between 2 points along the path that requires the least time as compared to other nearby paths. So that is the definition. So that means when light goes from one medium to another medium, so that means in the 2 points, the light will try to take the following path as compared to the other path where it will take the least time. That was basically the definition of Pierre de Fermat's principle somehow. So in the following slide, I will try to give you a briefly I will try to explain how we can understand the Fermat's principle in a very simplified example. So let us consider that Ujjwal, a very a young boy, wants to meet his friends Deepto. Yeah. So Ujjwal is located at the place A, and Deepto is located at the place B. Yeah, but as Ujjwal wants to meet B, in between them there is a long street, and in this long street there is a huge number of vehicles of the traffic. So now Ujjwal think, okay, I'll take a very short path. That means I'll go from A, C, and then I'll go to B. So that means A, C, B. But then Ujjwal immediately realized, oh no, this is very difficult because I have to go through a lot of traffic there. Yeah, so this is not really a very reasonable solution for him. Then he think, okay, let's go from A to E, and then from E to B. And there certainly from E to B there is less number of traffic, but on the other hand this A to E is actually a very long distance. Yeah. So therefore the Ujjwal decides, okay, for him the convenient would be if he follow the path like A to D and D to B. So that means now if you really make a little bit summarize the thing, so that means ACB, it's a straight path, but he must go through the traffic, so it will take more time. Now if Ujjwal wants to go take the path A, E, B, then it is certainly less traffic, yeah, but the path is longer, yeah, so it will take more time. Now if Ujjwal take A, D, P, the shortest way to reach the destination. So this is the way somehow also, this is the very general simplified example how the Fermat's principle works. So that means light try to minimize his time to reach a destination when travels from one medium to another. So now I would so far actually we are discussing the why we need light, and then we have talked about how light travels, and now I will talk about briefly about the composition of light, the light, these waves or particles. Yeah. So you know in 19th century, yeah, 19th century, that means last to last, previous to previous century, it was proved that the light was a kind of wave. Yeah, so light was kind of wave. That was proved, that was by this, according to the Young's and the Fresnel's experiment. So they proved that light is actually a wave. And then in the end of these last centuries, that means 1900 centuries, the photoelectric effect was discovered. Yeah. What does it mean by photoelectric effect? So you know, in some material, if you really if the light falls in some materials, so it actually generates the current. So that means the electric current. So that means you generate the electric current, or the electric current by the application of when the light actually falls on a material. And that was the things discovered in end of the 1900th century, and people used to call it the photoelectric effect. In 1905, the great scientist, the great mind personality Einstein showed that if you really want to understand the photoelectric effect, then you must have to consider, one has to consider, light is actually composed of not the wave but the particles, yeah? And somehow, and these particles are called photon. And because of this explanation, and in 1921 Einstein received Nobel Prize in physics, yeah? So that's really funny, and that's really interesting, right? For some people, the light is actually is a kind of wave, and that means the photon, which is the constituents of light, is the photon. So for some people, the photon is actually a wave, and some people, for the photon is actually a particle. So that means the light is actually a kind of polymorphic object. So and you know that this photon is actually massless. That is interesting. Whatever things you see in this world, everything more or less in our eyes, what we can visualize, we can see that they are more or less not massless. They have the mass or the weight, something like that, yeah? But the photon, the light we see, and the constituents of light doesn't contain any mass. So that means this photon is actually the massless. So that means that the funny thing, the light, sometimes some people called it a wave, and sometimes it is called a particle. So to summarize this, the light, the both particles and waves. So far we are discussing about many things about light. Now I would like to talk about the speed of light. And can somebody or someone knock out? So that means beat him by his own velocity. So that's a very important questions. You know, as a children, or as a school student, or as a university student, every part of our education life, we are told that the speed of the light is maximum, yeah, and there is nothing faster than this. So we are told, but on what basis? Yeah, that was the thing. You know, if you take the light, the velocity of light in vacuum is actually 300,000 kilometers per second. Yeah, so okay, exact value is 299 thousand something thousand kilometers per second, but that's approximately 300,000 kilometers per second is the velocity of light. So we know that the sun is actually located from the earth 150 million kilometers away from us. So that means the light will take only 8 minutes and 20 seconds to reach us from sun. Well, that's really super fast, yeah. So now according to the Einstein's theory of relativity, yeah, so according to him, the velocity of the speed of the light is maximum, yeah. If one can prove it wrong, or if some information comes that okay, something in this universe, or the world in this universe moves faster than light, then some concept of physics may have to be reconsidered. That is for sure, yeah. So you know, scientists and many bright-minded people around the world trying hard for many years, yeah. Example wise, in the year 2011, one Italian physicist, Antonio Erediato Ditato, shocked the world by saying that the neutrinos actually travels faster than light. Now, that was really a remarkable message for the scientific community. Anyways, even though it was later he was proven wrong, because there is a kind of experimental error, there is a kind of data acquisition problem in this particular measurements in the sun. So that means so far it is not a single experiment people have can done that proves that something is moving faster than light. So for example, take the man-made spacecraft, yeah. For example, Parker Solar Probe, yeah, which is the spacecraft is now in the universe that has been sent by the NASA, and the speed only 0.064% of light, and that spacecraft will actually go close to the sun, or in the sun maybe, and then they'll gather the information, a lot of important information of the sun. But this is only 0.06% of the velocity of light. This is really not much. Not only that, for example, in people also created a lot of fast particles that try to accelerate the electrons and more energies. But what happens? It can go close to the velocity of light, but never ever possible to beat the velocity of light. So what usually happens at the electrons gain the energy and moves faster and faster, it also increases or the changes the masses. Yeah. So that means what actually the main message so far in the scientific community, nothing can be moves faster than light in vacuum, and the velocity of light is constant, and in maintaining it, yeah, it mass may be changed or even time. Yeah. So this is how universe works. Interesting, isn't it? But if somebody can come up with the new ideas that okay, the light is not the fastest object in this universe, then it is certainly a new paradigm or new direction of physics. Okay, so far we are talking about how light moves and what is the constituents of light, compositions of light, and why light, and then we also talked about the velocity of light. Now let's talk about the color of light. Yeah, so we see usually the sunlight, the color of the sunlight is white. Yeah. Now let's imagine a situation, you take a white light, that is sunlight, and place the sunlight a little bit oblique way to a prism. Yeah. And in this prism, if you send the light, and because of the light has constituents, maybe many colors, so therefore they have a different refractive index, and so therefore they actually split it, and you see a kind of a splitting of you see in the visible region 400 to 700 nanometers, several ranges. Yeah. You see violet, you see indigo, you see blue, you see green, you see yellow, you see orange, you see red, and these are the more or less the normal color when you send your light in an oblique way through a prism. And then you see that that was the experiment by Newton's, and he found that okay, the different colors form a white light, and we call it Vibgyor. But the question is that do you really only have 7 colors or more than that? Yeah. So the question is that do you really have only 7 colors? We call it Vibgyor, and we also see in the rainbow. For example, in the background you can see I have even a background of a rainbow that you usually see after a little bit rain or something on the clear skies and a little bit cloud, then you see this kind of rainbow. So that means difference because of the different scattering, and then you see this kind of rainbows. How you see the visible light? Yeah, the light usually works that from some objects, light comes to your eye, that is the cornea, and through the cornea it goes to your retina, and then this is actually transfer the signal to your brain, and then you make the sensation. We call it the Vibgyor. There are only 7 colors, but in reality there are many more. So it's a combination of many colors. Yeah. For example, when you try to paint your house or take some color for drawing your children's and so you can make many combinations. Yeah. So sometimes dark green, light green, dark blue. There's so many colors. And the question is that how many colors we can actually distinguish. Yeah. The answer is that the human eyes can distinguish about 10 million different colors. That's a huge number. Yeah. And so equivalently, if you take some of the animals, they can actually, or the insects maybe, they can also have the ability to distinguish many more colors. Anyways, so with this actually I would like to end my first part of the presentation, the story of light. So in the second part I will explain you In the part 2, I will explain you some of the concepts, like some of the information, topics like man-made light, the light from electricity, and the electricity from light, and messenger light, and so and so. I hope you will also enjoy. I hope you will enjoy this. Thank you.